All right. New form for integration. Integration by parts. Now, one of the things that's nice about integration by parts, you're already used to doing substitution. Pick a u, get a du. Okay? You have a good idea of what's going on there. Integration by parts involves a double substitution. Right? So what we're going to have to do is we're going to select u and dv. We're going to select those two pieces. So we're going to split up our integral, select a u, just like we selected u in the past. Get a u, get a du. So we're going to break it up where part of it's going to be u and part of it's going to be dv. The letters are arbitrary. Just the common one is the u and the v. And if we did a and b, you'd have a, dv. Doesn't matter. Okay. When we select these two, this then creates, we're going to create du and v. So we'll get du from u. We were used to doing that. It's not a big deal. Whatever u is, du would be that derivative. Okay. dv, to go back to v, we'd have to integrate. So in other words, if I said dv, for example, was x dx, then v would be x squared over 2. I'd integrate back to it. We're used to doing this piece. We're going to add this piece in. Now, typically for an integration by parts, it involves functions, two different types of functions that we can't really combine. Let's do something like this. Let's go x e to the x dx. All right. Typically, it involves two very different functions. I think you would agree x is just a basic polynomial, very simplified polynomial. E to the x, that exponential function. Two very different ones. Right? Multiplying them together, that's about all I can do. There's nothing else I can really do to it. Okay? I'm still going to work my progression. So my progression says simple or basic trig, and it's definitely not that. Everybody agree? My next step is u substitution. Well, if I let u be x, du's dx. If I let u be e to the x, du's e to the x. If I let u be the product, then du's a product rule. Certainly not helping me. So u substitution is not working. It looks like it could be one of those specialty ones because of the e, but that's not going to take care of the x. Something like that. So if it was just an e, we'd say, hey, that's a pretty basic one. Not much going on there. Okay. But the x is throwing it. Right. It's not going to be that inverse trig. Again, still talking through my progression. So then the next thing I'm thinking of, is there any way I can manipulate it? So we've seen some things where we've multiplied it out, long division, some different things of manipulating it. There's nothing I can do to that pair. I'm just stuck there. I mean, I guess maybe I could bring the e down to the bottom, but it's not helping me any. I've still got the same two functions. Something like that. This is where parts come in. Right? So for my parts, right, I'm going to select the u, and I'm going to select the dv. U has to be x, e to the x, or the product. dv will contain the dx, so it's going to be x dx, e to the x dx, or the product dx. This is where I have to just try something. I'm going to let u be x, and I'm going to let dv be e to the x dx. We're going to then create our du, create our v, and then ask ourselves, did it get better? When I rewrite my new integral, if it didn't get any better, I chose wrong. Okay? It doesn't mean it's going to be easy. It better look better than the original. Easier than the original. So here comes du. du would be dx, or 1 dx. V would be the integral. So the integral of e to the x is e to the x. So now I'm going to rewrite using my parts and see if the integral part got any better. So I have the two different pieces. It's going to be uv. I have everything sitting right here. uv minus the integral v du. Sometimes you can tell by just looking at what's up there, is it going to work or not? Sometimes we've just got to write it out. Right? I would imagine for most of us in the beginning, we just need to write it out and go, all right, that's going to work, or it's not. Let me back up. So if I write it out, u times v, x, e to the x, u times v, minus the integral v du. Now I'm trying to integrate, so I'm not worried about this guy out here. It's done. I'm looking right at that integral. Is that integral easier to do than the original?
Yes.
Then I went the right way. So I'm going to integrate this guy, x e to the x, leave this here, minus the integral of e to the x is e to the x plus c. Now don't write this down, but I'm going to use the same one, flip it around, and you'll see what I meant by it looks worse, not better. Okay? So I'm going to let, in this case, u be e to the x, dv be x dx. So again, I got all my pieces taken care of. Use this guy. dv's these two. du e to the x, v x squared over 2. Does it look like I did it right? Took the derivative, integrated. Okay. Now let me write it out. uv e to the x times x squared over 2. That doesn't look great, but who cares? I'm not integrating that. It's out there. Minus the integral x squared over 2 times e to the x dx. That looks worse. The 2 doesn't bother me. I can pull the half out in front. It's the x squared. Now the power went up. Now I've got more trouble. That means I went the wrong way. Everyone okay with that? Huh? Let's go integral of ln of x dx. Now, this is something we haven't integrated before. Parts less gives us another way of integrating some things we can't do another way. You've never integrated an ln. You've integrated something to an ln, and that 1 over the single variable, but not integrated an ln. Okay? And just think back. I know it looks like a pretty basic one, but the natural log of x is the derivative of what? I don't know. There's the problem. It's not one of my basic ones. Parts comes in. I've got to select the u, and I've got to select the dv. In this case, I'm going to let u be ln x, dv be dx. Now I can't split the ln off the x. That's one whole piece there. So the ln of x has got to go somewhere. And let's face it, if I let dv be ln x dx, I didn't do myself any favors. I'm back to the same integral. End up with v. So now I integrate. du 1 over x dx. Please forget that. What's the integral of dx? Just x. All right. So now we're going to write it out and see if it works. Okay. So we're going to go uv minus v du. So let's see. X, ln x. And it doesn't matter if you write it ln x times x. I just usually if I do this, then I get kind of confused. Unless I use parentheses. I usually put it in front. The u times v minus the integral x times 1 over x dx. Then you're asking yourself the question, did it get better? Yeah, because those x's cancel, right?
Yeah.
Big deal there. This is looking a lot better. So we're going to have x, ln x, minus, and the integral of 1 would just be x, right? Now this is done by parts. I will say this. This is one that, as best you can, the more often you see it, we're going to see this guy a lot. It's going to be beneficial to you if you memorize that it's x ln x minus x. It's going to come back a lot. Okay? If you don't, that's fine. Parts works great. I'm just telling you it's going to be one you're going to see more of. Okay? Nothing wrong with using the parts there, though. Everybody okay there? All right. Let's go x squared cosine x dx. Now, before we work this problem out, you can notice real quick, we're talking about some of these specialty functions mixed in with some others. There's no way to manipulate them to combine them. I got logs thrown in, e's thrown in, trig functions thrown in. All right. U. What would you want U to be?
Cosine x.
All right. One said x squared. Let's look at this before you write it down. One said cosine x. And that's fine. Looks like either one will work pretty good, right? We don't know till we try. That's the key. So this one over here, and I'll give you a chance to copy it down if we figure it out. dv would be cosine x dx if you made that choice. Agree? And over here, dv would be x squared dx. Now let's figure out the du and the v, and then we'll decide which one's going to work. Sometimes both work. Okay, let's see. du, 2x dx. The integral of cosine would be sine. Does that look right? Okay. Over here, du would be negative sine. Not looking too bad. I don't care about a negative. It's not going to make anything any worse. V x cubed over 3. Okay. Now, the u times the v is not my concern because that's already integrated. No, we're worried about what's in the integral. So we're worried about this v du. So let's look at this. In the first case, I would end up with 2x times sine x dx. There's that v du. In the second case, I end up with x cubed over 3 times negative sine x dx. Which one looks better?
Definitely the right. I'm sticking to mine.
I was thinking about it. I'll write them out. I'm not going to worry about this negative, okay? That's just down front. Here's what it looks like. The negatives can always be pulled out. Same with the 1/3. That could be pulled out. Not going to change anything. So over here, I don't have a negative out front, but that's okay. All right, so did the left, look at your original, x squared cosine. Did the left one make it a little bit easier, or did the right one make it easier? Why the left one? Power dropped. It broke down. Is it easy? No. I didn't say which one. Did it get easy? Did it get better? The left one got better. The right one got worse because the power went up. This is one of those things that kind of like back when you first learned factoring. A lot of times when you first write it out, you're going to be wrong. I'm going to back up and try something different. It's okay. Okay? You got to pick a U. You got to pick a DV. If it works, it works. If it doesn't, you back up and repick. It's not a big deal. Okay? So let's get that first part down. Matter of fact, I'm just going to rewrite the whole thing down here. Let's see. This would be x squared sine x minus, do you want the 2 outside or left in? Outside, all right, 2 integral x sine x dx. Just write it out. That's what we're going to do with it till you get it down. And again, that coefficient being inside or outside, we've talked about that. Arbitrary, it's your choice. If you like it out front, get it out front. You're used to doing that. If you'd rather leave it in, leave it in. It's not going to change anything. Everybody like what we have so far? Now this is back to not a basic integral. You're back to going through your progression. The question was, did it get better? Yeah, it got better. Doesn't mean it's simple. Okay. None of my basic substitution or any of that kind of stuff is going to work, but it did reduce down to power. We still have 2 different functions, polynomial and a trig function. This is going to go through parts again. So this will go through parts a second time, because one time took it from an x squared to an x. What do you think the second time is going to do? I had to get rid of that x, right? Take it just for 1. Everybody agree?
Yeah.
Now here's the best part about it if you have to do parts a second time. All right? So I'm just going to, so don't get too low on the board, I'm just going to rewrite it up here. If I have to do parts a second time, the indication is because it broke down a power, and I know if I do it again, it's going to go down 1 more power and that part's gone. The nice part is you're going to use the same dv and u. And I don't mean the exact same, the same structure. So in other words, over here, u is going to be the poly part, the x, the polynomial piece, and dv is going to be the trig part, sine x dx. And we still got to find our du and v, but the nice thing for you is you're going to have sometimes a little trouble picking, all right, which one should be u, which one should be dv to start. If you have to do it a second time, it's going to be the same one again, 99.9% of the time. So it gives me a good place to start. Du here is dx. Integral of sine is negative cosine x. And we write out what we've got. So we now have x squared sine x. Again, that's from this piece here. Okay. What we did for this guy broke down this integral right there. Okay. So minus 2 times. And if you're one that likes to pull that coefficient out, use the brackets that help you keep things straight. uv, negative x cosine x, minus, which becomes plus the integral, because you can have a negative, cosine x dx. You still look at the integral piece and ask, did it get better? Yes, it got better. I can integrate a cosine. That's not a big deal. I'm okay with that part. That look okay to everyone? All right. Now, for those of you that would like to leave the 2 inside, well, that just means u would be 2x. So du would be 2 dx. That 2 is coming back out. All right, so it does not make it any more difficult if you left it in. All right? Most of you have been bringing it out. The only thing I would say is if you are one, and most of you are that bring it out, use the bracket here, because you got to remember the 2 is going to both parts since it was outside that integral. All right, so now we're going to have x squared sine x plus 2x cosine x. Integral of cosine sine, so minus 2 sine x plus c. Okay there. Let's go integral x cubed ln x dx. So now we got a log mixed with that polynomial x cubed. This is usually our indication of parts. Any of that substitution stuff isn't going to work when you try it here. I need a u and a dv. This will be a case where I'm going to let u be ln x, dv x cubed dx. Now, the reason is, right, I'm letting u be the ln. We already went through, I don't know how to integrate that. So if I put it on the dv, I'm going to have to integrate it. It's not my common integral. I don't want you to always assume that the more complicated function is always in the dv. It is a lot of times, but it's not always. We integrate. The reason I don't mind u being ln, the derivative works out pretty good, just 1 over x dx, right? What's going on? V x to the 4th over 4. Our next step, we write it out. So write out your formula, uv minus integral v du, and we're going to look and see if it's better. If it's better, we're good to go. If it's worse, we're in trouble because we have to back up. Thoughts? Better or worse?
Better.
So this is taking x out here, right? Most of you have been bringing the 4th out front. So I'll go minus 1/4 integral x cubed, right? Cancels an x out. Pretty basic integral there. I don't want you to think that every time the power goes up, it got worse. You need to really look at what the integral is. Did that integral get better from the original? I know the exponent went up here to a 4th, came back to a cube, but still, this is a basic integral. This isn't bad. So let's see, we're going to have x to the 4th over 4 ln x minus x to the 4th over 16 plus c. Since I had a 4th out front. Everybody okay there? How about x squared e to the negative x? Okay, what do you want to use for u? X squared, okay. Let me give you a hint. Don't think that hard. If you're wrong, you're going to find out pretty quick. Pick a u, pick a dv. You said x squared. Let's roll with it, see if it works. If it doesn't, we'll back out of it. And the reason I say that, you can usually find du and v pretty quick. Okay, so just get something down, try. You start recognizing things a little bit better later on. This is 2x dx. V here will be negative e to the negative x. Now, sometimes when you get over here going from dv to v, sometimes it can be a little bit difficult to do in your head, just depending on what it is. If you have to, you take a moment and you go out here and go, all right, that would be that. Use negative x. Du is negative dx, so I'd have negative integral e to the u, which would be negative e to the negative x. I don't know the plus c, but we're going to have that on the, go out to the side. Sometimes the integral is very intuitive and easy, like this guy. Other times it's not quite as easy to see where the negative came in, but you can easily go out to the side, write it out, see what you come up with. UV, negative x squared e to the negative x, minus, which will be plus, because we're going to have a negative, integral 2x e to the negative x dx. Better or worse? Better. That power did drop, right? Yeah. Dropped by 1, and that means if I do the same thing, it's going to drop again. Okay. So this time, since the time I did it before, I pulled the 2 out, just so you can see it both ways. I'm going to leave the 2 in this time. So I'm going to look at this part right here. U would be 2x, dv e to the negative x dx. I said go back to the same type u and dv that you did before. du 2dx v negative e to the negative x. Now, the nice thing is, if you had to go out to the side, and a lot of times you will, to figure out the integral right here, it's the same one again. Okay, so you wouldn't have to redo it. You already know what it's supposed to be. Okay. Now let's write it out. I'm just going to go up here. Negative x squared e to the negative x, right here, plus, all right, uv, so that would actually become a minus 2x e to the negative x. So remember, it's supposed to be a plus, but I had a negative here. All right, so there's where I'm getting minus my 2x e to the negative x minus my integral v du. That's minus a negative, so that's going to become plus 2 e to the negative x dx, and it's definitely looking better now. Now that x in front's gone, I can pull the 2 out front if we want, but we should feel pretty comfortable now integrating that e to the negative x. We've done it twice. And the 2's in front now, which makes final answer negative x squared e to the negative x minus 2x e to the negative x minus 2 e to the negative x plus c. You won't have to do all of them 2 times, 3 times, things like that. But you've got to make sure you're asking yourself, did it get better? If it got better, you're going in the right direction. You might have to go 1 more. And usually you can tell because that power dropped. And you know that if you do it again, it's going to drop again. So if I had started this problem with an x cubed instead of an x squared, what do you think would happen? You're going to have to do it 1 more time. Because it would drop to a square, then it would drop to an x, and then if I did 1 more time. But the nice thing is it's going to be the same parts pieces again. Okay? So I'm not saying that's never going to happen to you. That's going to be possible. But you can tell that it's getting better through each step you go through. All right. Homework.